So what is a function? Okay, let me give you the definition, and we can talk a little bit about it, and even more as the need arises. So the definition of function. So a function is the combination of three things: two sets, D and C, together with, and obviously we can change these letters as we denote different functions, but with a rule f that for every element x of D, there is an element in C. This element is uniquely specified by x. So there's not like several different elements and we could pick one to focus on. There's only one element. So there is y element C called the output x by f. Okay, so the set D is called the domain, C is called the codomain, so F is already called the rule, these elements, so the domain is also known as a set of inputs, so each element x is an input, and so the condition is every input has only one output. Okay, so there is one element y called the output, and this output is sometimes denoted, well, very often denoted by f bracket x, f of x. Okay, and there's several notations for the function as a whole. Okay, so I think a common one to say is you write the rule and then you write the domain, arrow, codomain, and if you want to actually specify what the rule does to certain elements, you write the element, say x, and then you draw an arrow with a line here, and you say where the element is taken by the rule. Okay. Sometimes if you're not so focused on the microscopic picture and you're only focused on the sets, then you could write notation something like this. And I feel that as the notation gets further down, it's becoming more abusive notation. So some people forget the domain and the codomain altogether and just simply write f, or they just write f of x and a formula. And the abuse really comes from now the forgetting of the domain and the codomain. And most people, like especially in the early stages of maths education, don't even bother to talk about the domain and the codomain as part of the definition of function. The domain seems to be something that's there to be discovered or to be computed, and the codomain simply doesn't exist, and it's replaced by the range. And I think it's an attempt to simplify it so that people can grasp it more easily, but I feel like it's almost impossible to grasp because they haven't really told you anything for you to grasp onto. And I think this while it's maybe a little bit more complicated, it does contain all the information that defines a function. And so at this stage, so you're not I don't think you're really required to know what a function is in the sense that you know what it does and you feel very comfortable with the function. I think at this stage it'd be good to focus on convincing yourself that something was defined. So something, what I mean by that is that the language is specific and precise enough that I've narrowed down one type of mathematical object in the universe of mathematical objects. And while you don't know exactly what it's for, why it's useful, and the insights that come with it later, at least you know right now that it is defined and it exists. Okay? And so that's what we're focusing on. And I think it's particularly important to have a domain because if you don't have the set of inputs, then, and the fact that it's a set is really saying that the inputs need to be very well defined to go into this rule. And the codomain is important because it's something that's also defined enough to be an output of the function, but it's less defined than in the inputs. It reflects an asymmetry of the domain and the codomain because when you have a machine you want to give inputs, it makes sense that you need to specify what you're putting into it or the machine might not work. Whereas unless you know exactly what the machine does already, you might not know what comes out of it, but you still do know the possible things that it could come out of it. And so what the codomain is, it's the set of possible outputs. So it's not the set of all outputs, because there might be something in the codomain that's not output by the function. We only require that every input, everything in the domain goes into the function, but we don't, and we require something to come out, one thing to come out for everything that goes in, but we don't require everything to come out. Okay, so for example, all the inputs could have exactly the same output. They could all output y. Okay, and that's a perfectly fine function. But y is only one element of the codomain. Okay, so the domain and the codomain are very important parts of the definition. The domain more so than the codomain, as we'll see later. And so while these notations are good if you really understand functions, I think their abuses are even more confusing when you don't really understand functions. And so let me give you a quick example of a function just to make use a little bit of our notation and see if you understand what it's saying. So let D equals the set 1 and 2. Okay. And C equals the set 0 and 1. No, 0 and 4. Okay. And then we define a function. So we define a rule. So f of 1 equals 0, and f of 2 equals 4. Okay, so this is a very simple function. Okay. And let's just check that it defines a function. Okay, so what does it mean to define a function? Well, we have two sets and a rule. Okay, so we have a set, that's a set of 1 and 2. So that's another set consisting of 0 and 4. Okay. And now what the rule has to satisfy is that it has to satisfy that every element of D, so every element of this domain or input set has to give you something. Okay, so every element there has to be some element of 0, and there is, because for 1 we have 1 gives you 0, and for 2 we have 2 gives you 4. So every one element does specify an element here. Okay, they could have both been 0 or they could have both been 4, but I just made one 0 and one 4, and so that actually defines a function. Okay, so a function is very easy to define, and another way we could denote this function is by saying f from D to C, 1 goes to 0, 2 goes to 4. Okay. So there might not be a formula for this function. I think most people have the idea of a formula in their mind when they deal with functions. And while a formula is an example of a function is a much broader concept and covers more than just formulas. Okay, so a formula is almost just the rule part of a function, and it tells you how to get the output number from the input number through an expression that usually involves multiplication, addition, and basic algebraic operations. Okay, so a formula is also an example of a function, but it's a specific instance of a function, and a function is a much more broader idea. Okay, so we'll leave it there for now.